Hello and welcome to the second part of 6.3. Today we're going to look at a few more properties of logs. The first property I want to show you is more in case you are ever in a course where you can't use a calculator, or if you don't have a calculator available to you that will automatically convert your base. Because in the previous lesson we talked about on our calculators, we either have a natural log button, which would be a base E, or we have a log button, which is base 10. Sometimes you're given logs of different bases, like you could have log base 2 or a log base 5. So if you have a base that's other than a 10 or an E, then you have to use what we call a change of base formula in order to use your calculator. So the way I like to kind of think about this, and this has worked for me for many years, is when I write out the log of something, I have a big number, which we'll call X, okay? And when I say big, it's just physically taller than my little subscript, which I'm going to call A. So in my head, I think about this as being my tall number and this here as being my small number. So for the change of base, you can see that we have three different formulas here, but essentially what we're going to do is I think about this as the change of base being the log of the tall being divided by the log of the small. So if you can remember that, it doesn't matter if you're using a base 10 or a natural log with base E, the formula is still the same. So log of the tall divided by the log of the small is the way I remember the change of base formula. So if we look at example 1 here, you can see that we have log base 3 of 16. Well, I can't type that in on my calculator as it stands because I don't have a base 3 log key. So what I would do is I would go ahead and I'm going to just use log base 10. So I'm going to do log of the tall, which is the 16. And then I'm going to divide that by the log of the small, which is the 3. Now, if you don't want to do a log, you can go ahead and do the natural log of the tall and divide that by the natural log of the small. And if you type that in, you'll see that you end up with 2.5237-ish, okay? Now, the same thing with part B, I'm given a log base 5. So I'm going to have to use the change of base on my calculator. So I'm going to go log of the tall divided by the log of the small, which in this case is 5. And you can do the natural log if you want to, or you can just do the log. It really doesn't matter. But either way, I'm going to get 1.9206-ish. And example 2 here is really the same thing as example 1, except it wanted us to use natural logs. So I apologize, I did that on the previous example, so you can skip this slide. Okay, and then the next thing about property or logs is we have a unique set of properties that allows us to simplify logs so that they're either A, easier to calculate if we don't have a calculator, or B, it's just easier to kind of rewrite them. So the first property that we have is called the product property. So if I'm taking the log of a product, I can actually separate that product out into two different parts. So I'm going to take the log of the first part, or the first number in that product, which in this case would be U, and I'm going to add that to the log of the second number. Likewise, this works the exact same way with a natural log. So if you're taking the natural log of a product, you can break that up into the natural log of U plus the natural log of V. Now, when I'm doing division or the quotient, if I have log base A of U divided by V, I can actually take that division problem and change it into a subtraction problem. So I'd get log base A of U minus log base A of V. Same thing with a natural log. Natural log, when I'm dividing, is going to turn into a subtraction as well. And finally, we have the power property. The power property states that if you're taking the log of a power or some number being raised to the exponent, you can actually take that exponent and bring it down in the front and multiply it by the log of then the base of that power. And again, that works for the natural log as well. So I have a couple examples using these properties and then, coming up. And so we'll look at those. And if you have questions, please make sure you write them down and I will answer them when we return to class. So for our first example, it says write each log in terms of the natural log 2 and natural log 5. So for this one, I can go ahead and say the natural log of 2 times 5, because 2 times 5 will give me 10. So if I want to write this in terms of natural logs, I can really turn this into the natural log of 2 plus the natural log of 5. And I can do that because of my product property of logs. Now for part B, I have the natural log of 5 divided by 32. Well, if I want to write this in just terms of 2's and 5's, I'm really going to have 5 divided by 32 is really 2 to the 5th power. So because I'm doing a division problem, remember, property of division for logs tells me I'm going to really turn that into a subtraction. So I really have the natural log of 5 minus the natural log of 2 to the 5th. And then one thing that I noticed real quick is I do have a power here. So I'm going to take this exponent and bring it down up front. So my simplified answer then would be the natural log of 5 minus 5 times the natural log of 2. And this right here would be my final answer. Example 4 is going to show us why sometimes it's actually nice to know all these properties of logs. So for part A, I have to take the log of base 7 of the 5th root of 7. So if I rewrite this using my properties of logs, I'm going to go log base 7. Well, the 5th root of 7 is really 7 to the 1/5 power. So because I have an exponent, I'm going to pull that exponent down up front. So now I have 1/5 times the log of base 7 of 7. And if you remember from the part 1 video, if I'm taking the log and the base is the same as the number that I'm taking the log of, remember this is really going to approach 1. So what I end up with then is 1/5 times 1, or 1/5. And notice I never had to touch a calculator to simplify this. Likewise, for part B, what I've got is the natural log of e to the 12th plus the natural log of e to the 5th. So if I rewrite this using my properties of logs, I can take my exponents and bring them down up front. So I have 12 times the natural log of e plus 5 times the natural log of e. And again, we had that property that said that if I take the natural log of e, that this is going to turn into 1. So really I have 12 times 1, or 12, plus 5 times 1, or 5. So this is going to give me 17. So the properties of logs actually can be quite beneficial. For example 5, we're going to expand this log. And the first thing I notice is that we are multiplying all 3 of these. So I'm going to start out just by writing log base 4. Multiplication, remember, turns into addition. So log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Now the only thing that I can see that needs to be changed is I do have this exponent. I can bring this down up front. So now I'm going to be left with log base 4 of 5 plus 3 times the log base 4 of x plus the log base 4 of y. And this right here would be my expanded form. For part B, I'm doing the natural log, and I always separate this up into parts. I try not to do everything all at once. So this right here, I could really write this as 3x minus 5 being raised to the 1/2 power. So if I do that, now I have the natural log of 3x minus 5 being raised to the 1/2 power. My division tells me that I'm really going to subtract the natural log of 7. So now when I kind of go back and I take another look, I see that I have an exponent that can be pulled down up front. So that's going to give me 1/2 times the natural log of the quantity of 3x minus 5 minus the natural log of 7. And here I have everything simplified because my natural logs aren't going to cancel anything out. My powers are all brought down up front. So it looks like I'm all set to go with this. Okay, so for our last two examples, we're actually going to go in the opposite direction. We're going to do what we call condensing. So when I condense, I'm going to end up with just one log function. So this is kind of like undoing what we've done in the previous two examples. So the first thing I'm going to do is I'm going to pull up any coefficients. So like I see that this 1/3, that really was an exponent on x, just like 5 was an exponent on the quantity of x minus 3. I also know that this plus here tells me that I had multiplication. So really what I had is I had the log of x to the 1/3 power times the quantity of x minus 3 raised to the 5th power. And the only other thing that I might do is that x to the 1/3 is really the cube root. So you could rewrite that as the cube root of x times the quantity of x minus 3 raised to the 5th, and that would be the log of all that stuff. So this right here would be my final answer. For part B, again, I'm going to pull my exponents out up front. Oops, right here on that x. I'm taking the natural log and I am subtracting, which really means division. So here I would have the natural log of the quantity of x minus 4 to the 4th power divided by, now one thing I want to caution you of, when you are dividing, you are only dividing this part here. You are not dividing the natural log because I'm really taking the natural log of this whole quantity. So I'm going to divide that by x to the 2nd power. And after looking through that, I don't see anything else that I can simplify. So then I'm going to go on to my final part for this example. And for part C, now this one here, I'm going to work inside of the parentheses first, and then I'll apply that exponent. So working inside of the parentheses, I have a plus sign here that tells me that we're multiplying. So I really have log base 3 of x times x minus 2. And then I still have that 1/5 out up front. And that 1/5 is really going to be taken up as an exponent. So what I end up with, let me slide this up here. What that's going to give me is log base 3 of x. Let's see, I'm going to put this in brackets. So I have x times x minus 2. And that's going to be raised to the 1/5. Well, the 1/5 power really is a 5th root. So if I wanted to, I could write that as the log base 3 of the 5th root of x times the quantity of x minus 2. And this right here would be my condensed form. Now, if you want one last set of practice, you can pause the video, try this on your own, and then come back and double check your answer. So for an expansion, this is a multiplication, and I have a power. So what I'm going to do is I've got log base 2, multiplication becomes addition, so log base 2 of 3, plus log base 2 of x squared. I need to take that exponent, bring it down up front. So my final answer then would be log base 2 of 3 plus 2 times the log base 2 of x. I can't cancel anything out, so this is completely simplified here. Likewise, when I condense, subtraction means I'm really going to be dividing. So this is really the log of x divided by y. And that's all I've got. Please let me know if you have any questions. Otherwise, have a great day, and I will see you in class later.